I am not surprised at all that somebody asked a question about number 63 here in 3.7. This is an incredibly tough problem, guys. This one right here is kind of the crowning jewel of everything we were doing here with the chain rule. Why? You need the chain rule when you're trying to take the derivative of a function that is a composition of two other functions. Or sometimes three other functions, or sometimes five other functions. Let's take a look at what we have going on right here. Focus on the variable, guys, and right there we see that x is being taken to the fourth power, and then just ask yourself what's being done next, that plus 1 right there. So our innermost function, I would say here, I'm going to not label these just yet with f's or g's or anything like that, but x to the fourth plus 1 is the first function here that something is being done to the x. Now, work your way outside from that. What is happening to the x to the fourth plus 1? All right, the way we write powers of trig functions is a little bit weird, but we're actually taking the cotangent of that function right there next. Then, after we get done with that, then we're taking cotangent to the fifth power. And we're adding 1, but that doesn't really do much to our derivative. So I think I can make this third function now a 1 plus an x to the fifth. And then, when you've got that 1 plus cotangent to the fifth of x to the fourth plus 1, everything now is being taken to the ninth power. So I would kind of interpret this here, guys, as 4 different functions that are being composed, where this would be f, and this would be g, and this would be h, and nobody wants to use an I, so maybe we would call that j. My goodness, that is a lot going on. So we've got our work cut out for us. The one thing I'm going to recommend that we do before anything else, guys, a lot of times I tell you, like with square roots, to rewrite them as something to the 1/2 power. I'm going to do something similar here with that cotangent to the fifth. So I'm going to rewrite the y right here as, and I tell you what, I think I'm going to change this outer set of parentheses into a set of brackets just for simplicity's sake. And then I've got a 1 plus, and when we write cotangent to the fifth of a power, what we really mean there, guys, is cotangent of the angle. I'm sorry, I misspoke right there. Cotangent of the angle, x to the fourth plus 1, and it's that cotangent that we take first, then we take that result to the fifth power. And so, there you go. I think that's the better way to write this function written out. Now, notice I labeled this, guys. This is still y. That's not my derivative yet. That's still just me rewriting the original function in a manner that I think is going to make differentiation easier. And now let's dive in. dy dx, here we go, is equal to... Okay, guys, the last thing happening, the outermost operation being done on this function is something being taken to the ninth power. So the way you take the derivative of anything to the ninth power is you bring that 9 out in front, and then you keep the base exactly the way it was. 1 plus, in parentheses, cotangent of x to the fourth plus 1, close those parentheses to the fifth, got it? And then we take all of that to the 8th power. But wait, there's more, times the derivative within. So now, what we need to focus on next is what's inside the brackets, the base of that 9th power, which is everything that I've just underlined in red. We now need to take the derivative of 1 plus cotangent of x to the fourth plus 1 to the 5th power. All right, let's get working on that. Well, the derivative of that 1 is 0. We can ignore that. Now we need the derivative of this. Well, what's going on? It is something, cotangent of an angle, to the 5th power. So its derivative is going to use the power rule as well. 5 times the exact same base. The base doesn't change. Cotangent of x to the fourth plus 1, got it, now being taken to the 4th power. But wait, there's more. Let me switch to green now. Okay, so the derivative of something to the 5th was 5 times the same base, the same something to the 4th, times the derivative now of this base right here. So how do we take the derivative of cotangent of an angle? That is going to be the opposite of cosecant squared of the same angle. So this is, I'm going to move down here, guys, the opposite of cosecant squared of the exact same angle now, which is x to the fourth plus 1. All right, still going, and guess what? We're still not done. Now, we need to take the derivative of the angle here that we were taking the cotangent of and multiply that as well. The derivative of x to the fourth plus 1 is going to be an x cubed. So holy cow, everybody, that's a mess. But that's when we're done. We've taken the derivative, I think, of everything we had labeled, right? We did the derivative of x to the ninth. That was 9 times junk to the 8th power. We did the derivative of 1 plus x to the 5th. That was 5 times junk to the 4th power. We did the derivative of cotangent of an angle. That was negative cosecant of the same angle. And we did the derivative of x to the 4th plus 1. There's our x cubed. So that's how I know that I'm done with the calculus. Now, let's see what we can do to simplify this. It's actually not that much, I don't think. What do I see for a coefficient? I got a 9 times a 5. That's it numerically for a 45. But there is a negative right there. So I'm going to pull that negative out in front as well. And that monomial of x cubed, this seems like a good spot to put that also. So boy, as complicated as this is, I should probably start, let me make this a little easier to see, crossing stuff out. I used the 9. I used the 5, I used the negative, and I used the x cubed. Ugh. Okay, gotcha. Then what's next? All right, we've got this big quantity in brackets right here raised to the 8th power. So let me put that here again. 1 plus. Now, I tell you what, the one shortcut I will do, cotangent of this to the 5th power, I'll go back and rewrite that as cotangent to the 5th of x to the 4th plus 1. Close that angle off, close that off. Okay, gotcha. And all of that was going to the 8th power. So I just took care of all of this and this. What's left then, guys? We've got this cotangent that I wrote here in red. So that would be times a cotangent to the 4th of the same angle, x to the 4th plus 1. So that took care of all of that. And then I think I just have what's in green left over, which is going to be times, sorry guys, I'm running out of room here, times cosecant squared of the same angle now, x to the 4th plus 1. And I am pretty sure, ladies and gentlemen, at that point we are done, and that's as good as that thing is going to get. So let's see where we ended up with that one right there. All right, the cotangent and then that cosecant are going to stay right there. And there we go. I just realized one mistake that I made, everybody. You probably saw it already. When I went to take the derivative, let me go back to purple here, of x to the 4th plus 1, that should have been a 4x to the 3rd power there, Mr. Fontana, which means this coefficient should have been multiplied by 4, and I missed that one. So my negative 45 is now going to end up being a negative 180, and there we go. Then that x cubed out in front there. All right, guys, that is an incredibly messy problem, but if you got that one, maybe after the explanation, you're in pretty good shape when it comes to understanding the chain rule.